Hello, I'm Paul Hancock, and welcome to the full-length presentation of my final project. My objective was to create a scalable and reliable website infrastructure that can handle varying levels of traffic and be easily improved and upgraded. In order to do this, I want to have all assets scalable, the ability to easily change the website assets, such as the pictures and text used, and also the ability to swap out databases as needed. Throughout the course of this project, I learned a lot and updated how I wanted to set up the assets and architecture of the site. My original intention was to make an elastic load balancer connected to an auto-scaling group that would pull web assets from an S3 bucket as needed. I then intended to have SQL queries from the site sent to a single app server, which would then communicate with the relational database service and return the results. Ultimately, I decided to use a single auto-scaling group to function as both the web server and an application server. This allows for better scalability and prevents a single application server from being overwhelmed with requests. I began by creating an S3 bucket and uploading a few assets I thought that I might need. Currently, only an image file is used from this bucket, but any other assets which I choose to add in the future can be easily accessed. Preparing the database turned out to be a very lengthy and involved process. I began by downloading a CSV file from Kaggle, the New York City Taxi Lost and Found dataset specifically. This data needed to be cleaned and converted into a SQL database so that it could be loaded into AWS's relational database service later, and then accessed by Maria database. I used convertcsv.com to begin with, and this converted the CS file into a SQL file. From there, I used MySQL Workbench to finish cleaning the data. This primarily consisted of using the find and replace all function to replace any spaces with underscores. Several column headers which use keywords, such as name, also had to be addressed. Finally, I was able to use MySQL Workbench along with the username and password I had set up to upload the file into Amazon RDS. Next, I created a load balancer in AWS so that the same web address could be used regardless of which instance was being accessed. I originally had two rules set up in order to split traffic between the two types of traffic. However, when I simplified my architecture to allow for better scaling, I only needed a single rule to direct all traffic to the auto-scaling group. The auto-scaling group is shown here with 5 instances running. The desired number of instances and the automatic scaling can be easily changed to accommodate varying levels of traffic. Care must be taken to ensure that the security group and availability zones coincide with the elastic load balancer, S3 bucket, and relational database server. Here, you can see the 5 T2 micro instances running, each of them running off an identical template. The user data section of that template contains the code needed to make the project work. This ensures that every instance is identical and provides a single point where updates can be made as needed. Here, I have taken the code from the user data section and organized it into 3 logical categories. The first category updates the repository, installs the necessary tools, and restarts services. The second category sets up communication with the RDS SQL server and the ability to handle SQL requests. By making a few simple changes to the code in this section, the example database can be changed out to a different database loaded into RDS. The last section of code changes the look of the website. The look of the website can be easily changed and modified now that the infrastructure has been set up. Changing the HTML text or sample SQL query is as simple as changing a single line in the template code. Changing the images displayed can be achieved by adding different images to the S3 bucket and changing a single line of code from there. This is what the site looks like now. While it is very basic, that can be easily changed, as mentioned. While it is simple, there are a lot of functions built into it. A SQL query form with a preloaded example is provided. This query will be handled by the connected relational database and display the results on a new page. More images can be easily added, as can video or any other website media that is loaded into the connected S3 bucket. Displaying the host name is an easy way to check that scalability is working. When refreshed, the page will show the host names of different instances and show that the auto-scaling group has scaled up as needed. Adding all these functions required learning from a myriad of sources and utilized a lot of different assets for the creation and running of the site. My primary reference source for this project was materials from this course and a few Amazon official guides. I used both Amazon Q and Microsoft Copilot large language models to troubleshoot problems as needed. When I was having trouble with the code to handle the SQL queries, I attempted to hire someone through Amazon IQ to help me troubleshoot. However, when I got up the next morning, rather than troubleshoot my problem, they had built an entirely new website on a new infrastructure using entirely different methods. So ultimately, none of that was used. Some of the PHP code was modified from code I found on Stack Overflow. The dataset was downloaded from Kaggle.com. And finally, I had a friend help me troubleshoot some of the code. A lot of different technologies also went into building the site. It uses EC2 instances in an auto-scaling group connected to an elastic load balancer. Assets in an S3 bucket and an RDS instance are used. The EC2 instances are Linux machines running MariaDB and Apache Web Server. Finally, MySQL Workbench was used to clean the data and upload it to RDS. Thank you for watching.